I'm still not seeing your slide deck.
You're not seeing it?
You emailed to Joe at JoJo?
Did you get Rick's?
I just copied from a thumb drive.
Joseph Jacks?
Yeah, Joe at JoJo.
Yeah, Joe at Jacks.
Oh, okay. Yeah, it just hasn't hit yet.
You can put on a USB stick?
Yeah, if you don't mind.
Do you have one?
Yes.
It's got a really messy bag right now. It's in here somewhere. Oh, I found it. Yeah. I'm sorry, what? Oh, awesome. Let me get him something for the meeting, and I want to talk to you then.
Okay, yeah. Go ahead, just leave it live for now if you want to go ahead and start it.
All right.
I'll just leave it live.
You just do what?
I'm just going to leave it on wide shot.
Go ahead and get it because there's a few people coming from outside.
Okay.
We should have brought the rest of the food in here if there's anything left. I love seeing a packed room. There's some spots in the front row. Let me know when you're ready, Jay. I'll go ahead and kick the meeting off. Welcome everyone to Charlotteiot. We're really stoked that everyone came for this big event. It's the first big event we've done, and the group's really come together, and a lot of people really helped out with this event. And first thing I want to do is thank our sponsors. First thing I want to do is plug in the projector. I don't see the end. this wire.
I just plugged it in anywhere, just saying. How many engineers does
Wait,
it take?
I see the end of this wire.
Oh.
Where does this plug into?
Maybe it disappeared now?
Okay. I'm running 3 VMs right now. That's a little bit slow.
Is that all?
Yeah. So this group has been growing like crazy. We've been around for like a year and a half, and we first did this meeting at Logical Advantage. No more. And then Graham mentioned having the meetings here at SNAP. And we've been grateful ever since then, having our meetings here. But we now have over 700 members, and we've done 20 meetings. And this is our first event that we've done, like our first multiple meeting with multiple things going on at the same time. And we want to thank a lot of people who helped with this. And first and foremost, Microchip and Atmel. I take it everyone had a chance to go inside the truck and to eat Moe's, and raise your hand if you went to the workshop today. But a lot of people saw the workshop and learned the Atmel stack and coding and an IoT framework for them. And we really want to thank Snap AV for this venue. It's really nice. Thanks, Graham. And
Burn the place down.
yeah, we try not
No
to.
promises, Graham.
And speaking of which, let me say my skill before the fire burns out. Alexa, ask Reader.
Welcome to the Charlotte Internet of Things. You can say hello.
Hello. That's how we greet you at Charlotte Internet of Things. Yeah, so you guys should come to my house on Halloween, because we've got like 6 IoT devices in there. Yeah, bring a fire extinguisher and your kids. But seriously, the board has been amazing for this. I've got a slide I'm going to show you in a second on just talk about the board, but let me jump to that real fast. But here's our board, and Graham with Snap, he did all the facilities. He organized everything with Atmel on where to park the truck, how to get everything connected, all the devices, and set up access points and everything. Just much appreciated, Graham. Rob, he facilitated the hands-on lab with the Azure Photon Lab. It was amazing. Everyone I heard good comments from the lab. And Joseph is streaming our this meeting, so we're live on the internet. And this is hopefully we'll be live on the internet. I hope it's working, but we may have some kinks to work out. And Mike is the swag king. Mike, he organized us to get the Echo through Hackster. He's an ambassador with Hackster, and Hackster has given us just really amazing things, including money every month. And most groups use that money to buy food, but we use it to buy more swag. And we used it to get the photons. So they gave us $100 a month, and for the last 2 months we stocked up on photons for the lab. So that's really good. Jennifer, she does all the newsletters, all of the media, and so anytime you guys get a news flash saying come to our cool event, we appreciate that, Jennifer. And she also has a Raspberry Pi, and she's running APIs on it that talk to Facebook and Twitter and Slack, and at some point we're going to get her to show us how it's all working. It's still a work in progress at some point, but it's also really cool stuff, and just amazing what you can do on a Raspberry Pi these days. I didn't leave anyone out, did I? Let me jump back to this slide, because I want to thank Charles Charles taught 2 Lua classes today. His second Lua class was streamed, and so it was not only the people in the classroom, but there was like 1,000 other people attending the class today. So it's just really cool that he was able to do that and stream it for the world. Oh, then finally our show and tell booth. We've been so busy I didn't even have time to fill out this slide, but we had a ton of people who helped out with the booths. Craig, Patrick, Clint had his tech turkey. I don't know if you guys saw the turkey that you control with your phone. It's a decoy. Patrick had a whole bunch of Raspberry Pi goodness. Craig Tucker had the ESP8266. And let's see, we had Mark Engel. He brought his boat. So we had a boat outside that the motor could tilt up and down through his phone. And I'm missing a few others. Who am I missing? But maybe I got them all. But anyway, so really appreciate everyone who helped out with show and tell. And I was working outside to do my Alexa hack, and I couldn't get it connected online. And I was trying for 2 hours to get everything connected. And so finally we brought it inside, and I want to thank Graham for letting us do fireworks inside the house. We try not to, but it is cool. Here's what the truck was if you guys missed it, and the Lua hacks. So we have a Slack account, and this is the great place where you have to be invited to it. So you can go to your Meetup profile and add your email address, and we'll invite you to Slack. But it's how a lot of the members talk to each other, talk about cool technologies. You can search the channels and get information, and there's plenty of activity on Slack. I need to be on it more myself, but it's Mike set it all up, and it's working well. Twitter, if you put your in your profile on Meetup, if you give us your Twitter handle, then we'll have it, and anytime you do something really cool, then we'll tweet you. So please do that, and we'll also try to follow you. But Hackster's been a great sponsor. They're giving us $100 a month, and here's some of the really cool swag that they've given us. Oh, and speaking of which, there's Hacksters needed. I've got on an Arduino board, I've got probably 6 of them, maybe 8. I'm not sure exactly how many we have, but those are an Atmel board that Hackster gave us, and it's Arduino, and it's got Wi-Fi built into the board. And I'm looking for someone to build some cool stuff, and then maybe do like a lightning talk in the group to say, this is what you can do with it. Same with the NXP Freedom board. So I've got those boards. If you guys would like to do something and then present it back to the group, that would be really sweet. And in July, so our next meeting date, we always meet the first Tuesday, but it's the 5th of July, and we're not going to meet the day after the 4th of July. So we're going to meet the following Tuesday, and it's going to be on Snap AV. And so Graham's going to talk about the Oversee product. And they just had a party not too long ago because they had their first 100,000 connected devices on it. And so it's really sweet. So I wrote 80,000 because my slide's old, and they're just growing like bananas.
It's 120 now.
120?
Yeah, we're adding about 8,000 a month.
Oh my God, so I should just go ahead and put 140 in for the next meeting. And the Regional Internet of Things, they're having a big meeting tonight on wearables up in Durham, and they have 250 people at it. But what's really cool is stay tuned, because we hope to be announcing an August meeting that's going to be a combined Charlotte Internet of Things and the Regional Internet of Things meeting. And it's going to be a really big meeting. So stay tuned for August. My company, Logical Advantage, does tech talks, and we'll have some posted on Meetup. I meant to have it before this, but we're going to be doing lightning talks for our next Meetup. It's going to be like the last Tuesday in June, and there'll be some really good topics, including Alexa and Mark. What are you talking on again?
You hadn't picked the topic.
So Mark's got a choice between 2 topics, and both very interesting. I forget the 2. One of them is Slack, like how do you use Slack well, and then the other one was something around security, I believe.
No, it was.
Oh no, it was on solid coding principles. And Patrick is going to talk about Xamarin, And so what we'll do is we'll spend 15 minutes to get like a really good introduction, and then it won't go too deep, but it's like if you want to learn about these technologies, they'll be great to come to. And a little bit about Logical Advantage is my company. I'm one of the co-founders of the company from 13 years ago. We just acquired a company. It's one reason why I've been so busy. But thanks to this awesome board that we have, because we acquired this other company and I got busy and they just like carried the load and pulled off this really cool event. But we do web, mobile, and IoT and game development as well. So, and we're also hiring people. In particular, if you're good in Node.js, and we need some back-end skills people and some JavaScript skills people. And if you're a good C#.NET person, then also please come speak to me. We do some IoT stuff, and we've done stuff with racing and medical carts, and including this shirt. If you it's not plugged in right now, but this shirt, normally if you tweet me, it lights up. If you tweet the company, it lights up. And so we have fun with stuff like that. And Rick, where's Rick? So Rick is our keynote tonight. And he used to work for a company called Yap. And Yap's a really cool company that did voice, text, and speech stuff in the cloud. So he's going to talk about that and a connection with a very big retailer company. But please come down here, Rick, and tell us your story.
Okay.
He also has like 20 patents. Is that right?
Yeah, something like that. There's a bunch in the pipeline. You always wait till you get this burst of junk. I feel like I'm with family. I've had a little bit of a chest cold. I think I'm not contagious, but my voice may, we'll see how much I have. I think it'll be okay. If not, I like an interactive presentation anyhow. And I see Mike is here, so I'm going to get lots of questions.
We have a watermelon as an anti-substance.
And we have a watermelon. So what could go wrong if you have a watermelon, right? Loaded up with...
I missed it.
Let's see what we got here.
I saw the manual load up, but I didn't see the IoT load.
I do have a Mac, but
All right, looks like we get to do the display thing again. That's me and some of my friends there. We were still friends afterwards too, which is kind of impressive.
I'll kill some time while he's getting that stuff. Rick was one of our first presenters at Charlotteiot. He presented on the iPod. He was one of this team built the iPod, and he showed us a prototype. It was like this big of what the first iPod looked like, which he's done some like amazingly cool things in his life.
I did not bring that this time, sorry.
You're still cool there.
Oh, thanks. Not as cool as you, Dan. So, IoT. As I always do, I have way more stuff than I can deal with in 1 hour. And like I said, I like to be a little interactive and get some Q&A because I always learn from you guys. So I killed off the IoT product challenges part of this, since it seemed like we were going to do some stuff with Alexa and speech and etc. So we'll go with the speech tech. Maybe the IoT product challenges we'll do another time. How many of you were at the Spark conference almost exactly 1 year ago today? Was anybody there? Of course you were. Mike was there. And I know Mike was in my presentation on the Edison. Were you in that one?
No.
Okay, good. So I'm gonna reuse some of those slides, and Mike, you can just shut the hell up, you know. So like that would ever happen. So IoT, okay. So I hate to say it, but I'm a little crusty and an old timer, and this highfalutin Internet of Things terms comes along, and I'm kind of like, what the hell, Internet, all the things, Internet of Things, kind of a lame term. But as it turns out, the term we had before had its own problems. So, you'd say this to somebody, some normal person, right? And they'd be like, what the fuck? Or else they would think it was something like this, and don't laugh, we've all done this. We've all been there. Here in Charlotte, you did have the option, since we're surrounded by bankers, you could say, it's the stuff inside of an ATM. And they would, most of them knew what you were talking about. Some of them were confused because they think there's little people inside of ATMs. So, and no matter how you slice it, embedded was not that great of a choice either. So, okay, fine, Internet of Things. It's nice that now I can talk to people and they kind of know, they may not really know what I do still, but they know it's cool, right? And that's what we need. So my journey started, my dad had all these kits he would get month by month from this company called Heathkit. It was kind of like Birchbox for nerds, I guess. Like most parents, he didn't have time to do anything with them, so he'd make me solder them all together. In theory, if you built all the kits, after a while you'd have this ham radio system, and I never ended up with that, but I did learn how to solder and kind of enjoy that sort of activity. My mom had this COBOL book that she took COBOL programming when she was in nursing school, which I think is pretty badass.
Daniel McCracken?
I don't know. It was big and blue. Oh. Anyhow, I would sit in the car bored and read her COBOL book while she was in there. So thanks, Mom and Dad. COBOL sucks, but it was a start.
It is a bit verbose.
Yeah. This is the first PC I ever programmed, 6502. Same processors in the Apple. Yes, that chassis is made out of bent steel. Yes, it would slit your wrists. Oops. Looks like we have an issue. Oh, we have a cable issue. But luckily, these guys came along and gave us the Apple, which eventually became this. And that's where I started my programming career. I actually wrote my first fitness program in 1983 when I was a freshman in college on Apple II. After I got out of college, let's say something about the Apple II. Up to that point, a lot of the hobbyist computers, they would slash your wrists, right, and stuff like that. They were rough. The Apple II had design. It was sort of that first spot where user experience sort of entered our industry. And it certainly wasn't an industry at that point either. Out of college, I went to work for this company called Zenith Data Systems, who, lo and behold, had purchased the old Heathkit, which was now making these PCs. And so Zenith Data Systems was making these portable computers, and these things had lead-acid batteries. They weighed like 17 or 20 pounds, right? They were the kind of laptop a CrossFitter would love. And this particular one was given to all the IRS agents, and they used it to go around torturing people with it. But Zenith Data Systems was run by a bunch of engineering cowboys, and they built new stuff that hadn't been done before. So they helped invent things like battery-powered computers. They helped invent, you remember when you used to have to pull the cable out of the wall on the IBM PC because there was the only way to cold reboot it, because the big red switch wouldn't even stop it? Well, Zenith Data Systems invented the button on your keyboard that actually would power cycle your computer. Pretty cool, huh? There's one of the projects I think Scott and I both worked on.
Yes, we did.
Godzilla, yeah.
Yep.
And there's the Intel SL386. That is the first processor that was designed for power-managed mobile computing. Everything up till then was a desktop chip that they just put lots of battery in and clocked it down and prayed for the best. So Zenith Data Systems, all right. I lucked out. After that, I went to this company that started out as, go figure, a radio company, Collins Radio in Cedar Rapids, Iowa. Eventually got bought by Rockwell, did lots of radio stuff for the military, whatever. A bunch of people broke off from that, formed a company called NORAN, once again, a bunch of cowboys, engineering cowboys and girls, off building handheld computers, vertical sort of market computers. So it's your delivery guy from FedEx or people doing barcode scanning were around, they might be using one of these NORAN computers. And apparently, according to marketing, Santa also used them, so that's pretty cool. Anyhow, these were some of the first mobile, tiny little handheld devices that would run desktop operating systems. And the reason they did that was to make it accessible to programmers writing in their sort of with their normal tools, right? Up till then, if you wanted to get code running on something like this, you had to use some weird programming language or operating system or environment, and it was just hard to maintain and handle. So sort of the bringing of standard tools kind of into the picture was what I take away from this. Also, radios. These guys were radio nuts. They invented things that were like Bluetooth and Wi-Fi and wide area radios long before any of that existed because they needed it for their customers. So they literally built their own radio silicon, although I think it was germanium arsenide. And they had their own chipsets. They built everything themselves. Again, a great place to be if you're a young engineer sort of coming up and learning how things are done. So yeah, NORAN, standard tools. Portal Player. So after that, a buddy of mine I'd worked out with at Zenith Data Systems started a company with a couple of his friends called Portal Player. And they wanted to build basically completely vertically integrated system for music players. So we had an ARM processor, we had firmware, we had an operating system, and lo and behold, one day, Tony Fidel walks by our booth and picks our chip, and we instantly were 90% of the music player market. So that was cool. Back to Apple. And also more design. And also, you notice their UI, making things accessible. So user experience, again. It's kind of hard to say the iPod was necessarily an Internet of Things device, but once you had iTunes and you sort of were moving music back and forth, that caused things like Napster to occur, and we all know how that turned out for the music industry. So thank God, finally, something with no goddamn radio in it, right? Oh, fuck. Turns out if you just put a display and a microphone and a radio in an iPod, you get an iPhone. Okay. Again, there's how it goes. Radios once again. The other thing with that big display, it gives you the ability to do things with the eyes that you couldn't do before, things with the fingers. So now we have the application ecosystem sort of getting invented. And the last company I worked at, Yap, I actually started at before the iPhone got going, and we were trying to get mobile applications running on the flip phones of the day. I don't know how many people tried to do J2ME apps in here. Did anyone ever try that? Sorry. You know, it was a terrible environment for trying to write apps, and you're on these little text screens. And then once you had your app, trying to get the phone companies to actually put it on the phone, as near as I can tell, probably involved bribery and stuff, okay? Because it was impossible. Apple came along and they pretty much led the way on fixing that. So kind of an ecosystem for delivering third-party application content. And again, lots more design. So speaking of design, there's a guy, Tony Fidel, who I worked with a little bit because I was the guy who brought up the first iPod development board. So I'm sort of the first person to hear music on an iPod, okay? But I brought it up for Tony, and he was kind of the father of the iPod. And he went off later and founded a company called Nest, and you're all familiar with Nest. And it sort of embodies kind of that one of those first realization points for the world about what Internet of Things was, because people could look at the thermostat and go, oh, there's this thing connected to the Internet, but it's also connected to my furnace and my air conditioner or whatever, and it does stuff for me. So you have the design element. Now we have the connected element, and on top of that, it has some, as you know, machine learning in it. So it kind of tries to keep track of your lifestyle and optimize energy usage and so forth. So Tony eventually sold that company to Google for zillions of dollars, although I guess he just got, he's unemployed as of last week, I guess. So if you need a good engineer, I guess he's available. Excuse me. And so that brings us to the last part of my tale, which sort of intersects with our little friend here. Right here in little old Charlotte, we had this company called Yap, and we did speech recognition. And we started out trying to do it for texting and driving type stuff, and that's when we kind of ran into issues with not being able to deliver our app. So eventually the pivot happens, that always happens, where you're at some trade show and somebody says, can you do A? And you say, do you have money? And they say yes, and you say, yeah, we can do A. Right? In this case for us it was voicemail transcription. I think voicemail is pretty much dead and gone at this point, mostly. But at the time it was still chunking along. I don't know if any of you remember the Google voicemail transcription at the time. It was almost a joke. It was like terrible. It's like, I think the word error rate, it was like 73%. Yap actually built an English language model for voicemail that ended up being about 93% accurate, which is very good. Voicemail is very hard to do if you think about it, and we'll talk more about speech tech here in a little bit. Voicemail is free form. You don't know what people are going to say. There is a pattern to it. You can constrain the domain a little, but by and large they can say whatever they want. Speaker independent, you don't know who's going to call, so you can't do any speaker dependent stuff. That makes it hard. And also people like to leave voicemails while they're standing in airports and when their dog's barking and when they're speaking in English while standing in front of a TV playing a show in Spanish, okay, while the kids are screaming. So tough problem. We did a pretty good job of solving it, and while we were doing it, we also were working on our own engine, speech engine. We actually had the guys who did the Dragon engine, if you're familiar with that, and some other people. Well, we eventually got acquired by Amazon. That was in 2012. It was supposed to be a big secret. I believe my NDA ran out about a month ago, so I can sort of talk about it, but I don't want Jeff hunting me down. So they wanted to keep it a big secret since they were working on some stuff. I don't know, but I assume some of the stuff's in there. I don't know. Anyhow, we worked on speech. Amazon bought us. They delivered this. That's all I got to say about that. What I do today is I have this company called Charlotteiot. It was supposed to just be a company for my patents, to hold my patents, but then people started calling me to do stuff, and I kept saying yes because they kept giving me money. Excuse me. So that's what I do today. I'm a consultant. I kind of joke about a lot of my jobs are what I call Winston Wolfe gigs. If you ever watch Pulp Fiction, he's the cleaner who has to show up and fix things when they blow their friend's head off. In my case, it's a little easier. I don't have to deal with headless bodies. It's just usually misplaced ones and zeros, right? And I never have had to show up in a dinner jacket before, although I would do that. That seems cool. And I've never gotten the cute junkyard girl after a gig before either. So that's what I do. I get to pitch myself since I'm here. If you know anyone who needs something complicated fixed, I'm around. If you're 15 minutes away, I'll be there in 10. So here's some of the points I kind of ran across while I was kind of running through the kind of where my personal path has led, many of which are sort of keys to IoT suddenly becoming something. I forgot to talk about moving some atoms. One of the things Tony Fidel, I guess, said was he wasn't interested in just moving electrons. He wanted to also move atoms. And so, especially in Charlotte, we do a lot of what we do in Charlotte is software. It's just moving electrons. But there are places, and a lot more as we go along, where it's more about moving atoms around as well. And so I think that's kind of important for IoT, is it is an Internet of Things, and the things are made out of not just electrons, but atoms. So embedded, of course, low power, the maker culture, building stuff yourself, getting your hands dirty, radios, design, a user experience focus that's not just about a piece of software, a 2D experience, it's about this device that can kill you in this case. You know, probably should have some user experience there, Dan.
You can have some experience with it.
You won't be a user for long. Okay, so Internet of Things. I guess I love you after all. Yay! I did this talk a little bit like this a year ago, like I mentioned, and I put up the Gartner Hype Cycle, which has Internet of Things up there at the top, right? I actually looked at the one from 2015. This is the 2014 one. And the 2015 one still had it at the top. I guess it's stuck there. I would have thought it would have moved down a little bit. I'd also like to point out, if you look way over here in maturity land, you'll see speech recognition, which I think is a hoot. Because although some things have been solved in speech, it's got a little ways to go, in my opinion.
It's getting worse.
I think it's getting worse in a way. I think maybe what's happening is it's getting usable enough that we all now care about the ways it's broken, possibly. So anyhow, so I guess we're up here still or something. Unfortunately, we're headed, down to this trough of disillusionment, apparently. And Grumpy Cat says, "No, I don't want to do that." So I would think we'd be about here, you would think. And that reminds me of another thing I'm familiar with that has this shape. Which I actually kind of like. It's a little scary. But you eventually end up looking like this. So that doesn't seem so bad, right? St. Edison had this to say, and I think for this group, this is about the truest thing you can ever say. And at this point, in wherever we are in the hype cycle, I think we can all agree for sure that we have a lot of junk right now to play with. Okay. Apparently, there's trucks going around making you go into the truck and you come out with more junk. Apparently, so it seems like a good time. I'm gonna drop back here. I love Grumpy Cat. All right. Is there anything that popped into anyone's head that I missed here? Just before we cruise along.
I have a question.
Yes, sir.
When you say moving atoms, be more.
Building cases and circuit boards and like you guys spraying foam all over the place and
Spelling IBM with Xenon at.
like that, and burning things down, causing the fire department to show up. That's a lot of atoms, right? And then they spray a bunch of water atoms in, and so it's kind of a statement about not just doing software, is what it amounts to. All right, where are we at here? Okay, not too bad. Only went 15 minutes.
One of the things that's missing from your list that I was just
I bet you're going to tell me.
IEEE's robotics and automation meetup yesterday, and robots have come a far way, and they're going to come even farther, faster.
So
Expect to start running into them.
kind of like actuator technology. Yeah.
Little things actually moving around, and some
Yeah,
of the
definitely.
stories some of the guys working at iRobot told me.
Yeah. I love my iRobot.
Till it kills you.
Yeah, till it slits my throat in my sleep while it's cleaning the house. So let's talk about our menu. I love the Swedish chef too. I'm not going to say bork, bork, bork. Oops. So what the hell, I mean, I don't really know if anyone in here is actually doing anything with speech or cares about it that much. I mean, is anyone working on any product that's going to do any skills, or are they thinking about it, or is it just interesting at all?
Sure. That's
Okay,
pretty cool.
well, of course you are. You're interested in everything. Well, so what I have is I'm going to go through some of the basics of speech tech, and with an eye towards not that you want to build your own tech, but more in the sense of what are some of the things you might want to think about if you're going to do a product that has speech tech in it. And I apologize if it's too simple. Ask questions if you have them. So we're going to do basics of a speech platform. We're going to talk about some of the speech model types. And a speech platform I'm using as just it's a place where I can send audio and get some sort of result back. A model is a thing that defines how that speech will be transformed. It's sort of like the software for speech. And we'll talk a little bit about picking speech tech that you might want to do. All right, so here are, and this is a very classical look at what a speech system, kind of the basic stages it has. And believe me, there's lots of other takes on this, and many of them are not out of the labs, and I'm just going to go through some of the basics here. So the first thing you do when you want to do speech is, wait a second. I skipped that whole list, didn't I? Okay, sorry, I didn't. So the first thing you do is you get a bunch of audio, and right off the bat, speech systems are picky about that. You'll find that they use 16K mono audio is kind of the gold standard in case you ever care. If you're putting a microphone and a converter on your board, make sure you can at least do 16K mono PCM, and you'll probably be okay. They work with other things, but that's what all the researchers tend to have their test data in. So the front end on a system is just doing all the audio things you might expect, which is probably chopping the bandwidth down to the range that a human voice is in, and doing a little bit of noise filtering. Whatever they have for noise filtering, that's where they'll do it. So you get this audio back out that's been filtered. At that point, they're going to do some voice detection on it, and if they see audio that looks like a voice, they're going to warp it. And what that means is my voice has a certain frequency. A woman's voice will typically have a higher frequency. A child will have another frequency. Some of us talk really slow. Some of us talk really fast, right? If I had to build a model for every single variant of those, I have this huge, I have to get all this data from people who talk at those rates and pitches, and then I have to build these zillions of models, and they'd be huge, and I'd never be able to run them. So they try to fake it by trying to detect the cadence of the voice and kind of the base fundamental frequency, and then they try to warp it all to one frequency and one sort of speed. So when you hear them talking about warping, that's what's going on there. Probably not something you have to worry about, but that's how they do that. After that, we start getting into the place where we are converting each phase of data that we have into symbols and intermediate sets of symbols. And the best way to talk about that, I guess, is to say you could have a system that all it did was hear any audio and then map it directly to any result. So, for example, you could have all the audio that could map to, I'm getting an address for some location, okay? Could be in every human language, maybe even the humpback whales, because they want to know how to get to Baja in the spring or whatever, right? You don't care, it's just audio. Show me all the audio patterns that map to going to an address, okay? That's not going to work too well, again. It's too big of a problem and there's too much data. So the problem is broken up into a pipeline of different symbols, and every company can choose to do this a different way. This is this particular collection here is kind of the classic statistical way of doing it. So the first step is they will typically chop the audio up into 10 millisecond chunks, and they will do frequency extraction on there and some other math, and then they will use that to build what we can call phonemes. And they're probably not the ones you got from Hooked on Phonics, right? They're ones that people wrote their PhD thesis on, for here are the phonetic, the best phonetic mappings for North American English or whatever. But there'll still probably be like 30 or 40 or 50 or maybe 80 of them, something like that. So you take these strings of 10-second audio and you train them on a bunch of audio you have where people have gone through and typed in the words very exactly that the speaker was saying, right on the time boundaries, so that you can look at the audio and train on that. And after a while, you have this model that says, when I hear this sound, it's probably an yeah or something, right? Okay. So that's your first level of symbols, phonemes or whatever. Well, obviously that's not super useful. When you type it out, you might be able to sort of tell what it is, but that's not usually what you want. So there will usually be something along the lines of what's called language modeling. And language modeling is more like what are the words people speak, and what order do they usually come in? So for example, we had a voicemail language model that we built. That was the thing that got us our accuracy mostly at YAP. And the way we got that was by getting a whole bunch of voicemails, sending them to some fairly expensive transcriptionists who would then type in very accurately what was said in the voicemails, and then we would train on those. And after a while, you would have a model that knew how people talk in voicemails. And this was a domain-specific language model, and that's very important. So if you want to drive a voicemail speech recognition company salesperson right up the fucking wall, okay, when you test their system, go and say something like this. Testing. Testing. 1, 2, 3. Testing. Right? And it'll fail. Why is that? Nobody leaves voicemails that say that, ever. Or do what's known as robo-talking. So if you listen to a human talking, we talk in continuous speech, okay? Discontinuous speech is robo-talking, where I put a space in between each word as I say it. And you will be surprised how many people think they can test a system like this with that speech because they think they're helping it by breaking their words up, right? You're not helping it. So language modeling knows that these phonemes all get piled together in these strings. It knows statistically, when I see these 4 words, what's the probability that the next word is these 3 things as it goes along. So if you imagine somebody saying a sentence, actually, how many people, I think Siri is doing this now, how many people have seen the speech systems where as you're saying it, it starts putting the words up, and then they start changing while you're still talking, right? Well, part of that is because, of course, you don't know the statistical probability of a word at the beginning of a sentence until you hear the word at the end of the sentence, especially in English, right? And so it'll be going along just like a There's another feedback mechanism that happens here as well. So the language model, the acoustic model will come up with a hypothesis. In fact, it'll come up with a bunch of them. It'll say, here's the different probabilities that these are the lists of companies or whatever, symbols that I saw. Here's the language model. See if you can map this into some words that somebody would say. Language model will look at that set. It'll go through its model and say, well, here's the 3 things I think they probably said. But if they really said instead of here's something that's way more probable. What do you think, acoustic model? And the acoustic model will look at it and go, yeah, I think you're right. They could have said that. Yeah, and they'll kind of go around, all right? And eventually they'll agree on a hypothesis, and that will move on to the next phase. So one thing that's important here, again, if you're testing a system, a language model knows about different patterns of speech in different places, not just one place. An acoustic model knows about dialects. Like the US has about 7 dialects, accents if you want to call them that. And then there's an 8th one called Army Brat, which is the one I got because I moved around a lot. So I can talk like I'm in Michigan, like, hey, Ole, stop that rag in the gas cap and let's go poach up some deer, eh? You know? Except that I said that really fast, like, you know, I'm from somewhere else. And that's the problem. If you ever go test a system, we saw this a lot, people would be like, I wonder how it's going to be on a southern accent. So they would say something and what they felt like was a southern accent. And it might have acoustically sort of been it, but they didn't use words that any southerner would string together in that order. And so you have the acoustic model going, I think there's a redneck here. And, and the language model's like, rednecks don't say that. That sounds like some Jewish dude from New York, you know? And then they go back and forth and they'd just be like, pick one, I don't care, you know? And they'd be like, confidence 45%, and stop fucking with us while you're at it, you know? So testing is fun. And you have to use real users to do it. Last stage, and this is where all the fun is happening right now, especially with our friend here on the desk. So context, metadata, whatever you want to call it. Once you have language, and again, it's convenient for us when we do speech to turn it into what looks like the written word, because that's what we're used to. Keep in mind, that's not really what we typically want anymore as an output. If somebody's asking for an address, there's no particular reason to turn it into an English representation of that address, written address, before we go look for it, other than if we just happen to already have a database index that way, that's how we do it. But keep in mind, you don't have to do it that way. You can index anything based on how somebody talks about it without turning it into written text first. I don't know if that makes sense or not, but that's a phase we're getting to. Your brain does not turn an address into little pictures of text in your head that you then look at and go, oh yeah, they said blah, blah, blah. It just filters down and finds the address. So context and metadata comes into that in the sense of a string of words or symbols is always ambiguous. If I have 2 friends, I live over on Lake Wiley over here, and they both leave me the exact same voicemail. They say, hey, Rick, I'm going fishing at the bar tonight. You want to come? One of them's talking about taking his bass boat out, and one of them's looking for a wingman to go over to T-Bones and meet some ladies, okay? I only know the difference because I know my 2 friends. I know what they're up to, and I know what they do. And so you use that information about context to help you repair things you hear, because we feel like we hear everything, you know, correctly. But the reality is most humans are recognizing at a rate of about 95%. It's just that the stuff we miss doesn't matter that much. For example, in voicemails, you could get away with a lot because most people, when they see who's on the caller ID, who's calling, if they know that person, that's more important than it's somebody they don't know. Okay, so automatically we filter down to they know somebody, whatever that somebody says is now more important, right? The other good thing is once you know who's calling you, you already know what they're going to talk about. You know what they're going to say. 99% of the time, they're replying to something you're asked about, or there's somebody you always talk about the same things to. That gives you the impression, when you read that transcription and we totally screwed it up, you still kind of know what they're saying, just because you know what they were talking about. As long as we sort of get the yeses and the nos right and things like that, you know, the human brain is plastic enough that it'll help you out. Well, this is the part that context is trying to help with. So although Google's voicemail transcription sucked compared to Yap, The one thing they were really good at was addresses. Guess why? They had lots of address data to train on. They also knew more about their callers and their listeners. And so when an address showed up in a Google voicemail, they could get that right because they could narrow it down. And we just had to take a shot at it as if it was just words. We didn't really know which addresses meant more to which groups of people. So that's an example of how context was used to make things accurate. This is starting to get into the area where if you work with a product that has speech in it, you'll actually be able to make a difference because you may have context information about your users and what they're doing, and you may be able to find ways to plug that in and make any transcription you do more accurate. What else about metadata? We had a competitor called Spinvox that we actually put out of business. They were telling people they were doing automated voice recognition, but they were actually using teenagers in like the Philippines and Egypt and whatever. And one of the ways you could tell was, of course, when you sent 30 seconds of audio to Yap, we would be done with it in about 30 seconds and send it back. It would take these other guys like 5 or 10 minutes. But the real clue was that either Philippine or Egyptian or Indian proper names would be spelled perfectly every time, right? And you'd be like, how did they know to spell that right, you know? And it turns out it was not because they had a database, it was because they lived there and they knew how, right? That's the kind of thing you can do when you have context and metadata. And in this case, those poor teenagers doing all that typing, they had it, and we didn't. Funny war story, the way Spinvox finally went down was, I believe, there was a lawyer or an attorney or a doctor in London who was using Spinvox for their voicemail transcription. And Spinvox was this party animal startup that spent all their money on barges on the Thames and jets and things. And they would hire a call center to do transcription, not pay them, and then just move on to the next one, right? So eventually, I believe it was some kids in Egypt, in their transcriptions, started putting in little cries for help. And they'd be like, I'm Ahmed, I'm in Egypt, and Spinvox hasn't paid me for 3 months. Please tell Spinvox to pay me. And you're a doctor, and you're on this supposedly private service, right? It's private, right? And it's automatic, right? And you get this. And obviously that didn't work out too well. So. Bless their little hearts. Try out my fake Southern accent. All right. So here's a few things you have to pick if maybe not so much these days, but it could still come up. If you're looking at the speech services like Watson or Google's going to open theirs up now, you can get on the beta or the alpha, whatever it is, if you want. Probably everyone will open up their speech engines for us to play with, one point or another. On the acoustic model, they'll usually want you to pick a bandwidth, and they'll call it something like high or low bandwidth, or they might call it a telephonic model. All that means is the audio that they trained that acoustic model on was either 16 kilobit audio, which is usually going to be the high bandwidth or medium. Low bandwidth would be like 8 kilobits, and then they may call the low bandwidth one telephonic, which means they actually train on usually cell phone audio, because as you probably know, cell phone audio runs through these codecs that does a bunch of compression and stuff, and that changes how your voice comes across, and that actually wrecks the recognition if you don't train on that actual audio. So if you know that you have people who are leaving audio from a cell phone or whatever, if that's a thing that's going to happen a lot, as opposed to I just have a microphone, there's somebody standing there talking to me, then you have to worry about that kind of thing. On the language model, obviously the language. It's harder than you think to do even just a Spanish versus English language detector, because we did one at Yap. I think we got it to maybe 75% accurate, maybe. So usually you pick a language. probably Google and the others are better at it than we were. Dialect, you may or may not have to pick. The model we built had, we didn't specify dialect. It was just, you could be any English speaker. And then more importantly, domain. So domain is the thing where if you have a choice and you may not, they may say, here's what this model was trained on, here's what the training set was, and here's what people were talking about. It used to be, in the old days, everything was trained on what was called broadcast news. So they would get all these recordings of the broadcast news because there was already transcripts made, right? It was kind of a cheap way to train a model. And so as long as whatever you were doing, people talk like they were on the evening news announcing when the weather was, and hey Alexa, what's the weather today? Oh, you don't like my announcer voice. Okay, if you had people talking like that, then it would work, but you didn't, so that's one of the reasons why those models weren't very accurate. These days, they'll have sort of a general English model, and they may have a texting or messaging model. Probably no more voicemail models, because nobody cares about voicemail, but you get the idea. Yes, sir.
So, what do you think is happening on YouTube then? Because YouTube has this sort of, on-the-fly transcription, at least what appears to be, mapping to the actual video as it's going through, that interactive transcript thing. Because that domain is wide open. You can use anything on YouTube.
Yeah, I mean, Google and probably Google mostly, since they own YouTube, that's their engine. And I'm sure it's completely freeform.
Well, I wonder too, as you upload a YouTube video, you pick a category.
They probably use that.
And I wonder if that...
They'll scrape every bit of metadata they can. They might look at if you've already uploaded videos in the past. They may take a crack at, well, maybe they follow the same types of, things. And then once you have, we'll get into this a little bit more. Once you take a first crack at transcribing something and you have some raw data, you can sort of go back and try to match it to everything else. And if you find a bunch of other stuff it matches, then you go and cluster it with that and say, well, let's fix the errors so that we're more like those things, because that's probably what we are. Like maybe we're a video about a soccer game or whatever, or a birthday party or something.
So are you saying that as human speakers we tend to say the same things?
Yes,
Same types of
about the
things?
same. We talk about everything kind of the same way. Ourselves.
Can you elaborate on that?
So the voicemails is a good example. Average voicemail was 24 seconds long. They tend to peak at 4 to 5 p.m. when I believe everyone leaves voicemails to their coworkers to dump work on them and then races out the door. With the exception of our Boost Mobile customers, who, if you know anything about Boost Mobile, they're a little different breed. They talk a little later at night and they talk about a little more racy stuff. So, whereas our typical
Is that domain specific?
I'll just say this, if we'd ever wanted to build a fake orgasm detector, we had the data for it. Okay? Just saying. I don't want to build one. Okay, that got my train of thought a little messed up there.
Can we talk about the same things?
So you're leaving a voicemail, kind of a general template, and there's a bunch of templates, is, hi, this is so-and-so, even though they have caller ID, but we still say that, right? Hi, this is Rick. Then you introduce the topic of your discussion. You say, I'm calling because my plane is delayed or whatever. And then generally you will say what you're going to do about that situation. Or if there was a information you needed to deliver, like a yes or a no to some question, you'll give it then. And then you'll finish up with sort of the final, the sign off, whatever you do to sign off. See you Thursday, blah, blah, blah. Click. And that pattern repeats itself over and over and over and over. There's some other ones, but by and large, that's what you see. And so that is a domain. And when you have domain-specific training data, it inevitably makes your accuracy go up. And this is not just because this is computers doing it. This is the same for you. If you were listening to a show on TV, and somebody, you heard the announcers start talking like they were leaving a voicemail, your accuracy actually would go down. If I came back and asked you what they were saying, your actual accuracy would be lower because you would hear things that were not there and you would miss stuff that was there. Simply because your brain is wired up for, I'm listening to announcers on TV and it's already making assumptions about what they're going to say, and those will end up being wrong.
So I get that from a context perspective. If you're watching the news or if you're leaving a voicemail, those are definitely certain types of speech or types of communication. My question is, when Rick talks, does Rick, is
Yes.
the system going to be able to
Yes, yes.
get, this is what Rick talks about, this is
Yes.
how Rick talks?
Yes, so if Yap had continued by itself, we would have ended up going down the road of, we know, start collecting caller IDs on voicemails, right? Then we can at least sort of narrow down, usually it's only one person who ever calls on a number because it's a mobile phone. It might be a home phone where there's a bunch of people. But that lets us start narrowing it down to, oh, this is Bob talking, and we know how Bob talks. We've heard Bob leave all sorts of voicemails, right? And suddenly our accuracy goes up again. So again, context.
Well, if Bob leaves a voicemail, Bob's voicemails are almost always going to be identical. I'm thinking in terms of if Bob's talking to Bob's friends, does Bob tend to say the same things?
Oh, absolutely. Yeah, and the relationship is the same as well. When Bob is talking to Rick or Bob is talking to Mary, you can have a different model, a different context for sure. And that's definitely where we were going to go next because that's the data we had. We didn't have all the Google data, for addresses and things like that. Let's see if we can get the video going again.
Just a curiosity, is neural networks used or fuzzy logic engines used in any of?
Yes, neural networks is another big, there's like three big families traditionally. It's neural networks, it's the statistical based ones that use GMMs or HMMs.
Hidden marker.
Yeah, hidden Markov models. And there's another one that I forget which one it is. And I assume at this point, everybody in their labs is working on some other variants because you see it leaking out in papers and stuff. And it's been 4 years for me since I was working on this. So, I'm sure a lot of stuff has happened. Yes?
How is data for these things typically stored? Like I remember the Dragon Naturally Speaking apps, I guess it was all just embedded right in there, but what kind of databases would house this information?
The context or
all
the language models?
And the model and all
Okay.
that other pieces.
That's a good question. So our, and this brings up an interesting thing about speech, I guess. You hear about a speech engine like Dragon or whatever, and it sort of gets all the glory. It's like, oh, the Dragon engine, Well, we were running an engine that I believe is about 160 kilobytes of code. But the speech model it was running, which is where the family jewels were, was about 4 gigabytes of RAM. Once you got it into memory, that's where all the magic is in the models. And the engines are just kind of like, they know how to run an HMM really fast and, stuff like that. But when you're talking about where does the data get stored, it depends on what kind of system it is. So given that we were freeform, speaker independent, in theory, we didn't have to store any data. We had one model. It was for everyone, right? We didn't care who it was. You're going to run through this model. Now, if we'd started down the path of doing adaptations once we knew more about each user, that we would definitely start storing. Again, that's not a whole lot of data. And then you do want to store some settings, like simple stuff, like, well, the most important one is the anti-profanity filter setting, because you'd be surprised. The F word gets converted. Apparently people say that a lot in the test data. And it's one thing when, that creepy uncle or whatever leaves an accidental F-bomb, but when it's your granny, you just don't want that stuff showing up.
Or your pastor.
Or your pastor. And the word sex. Everyone must say sex or something because whenever the engine would be like confused about, I don't know what the person said. I guess they said sex. Let's put that. Right? It's like, okay, maybe that is what we always talk about. I don't know.
Are the speech engines now capable of doing larger censorship then? Like, I don't know, could they do that?
Oh, sure.
I guess.
Yeah. To the extent that they want to do machine learning on that and build the pattern matching and whatever. Yeah.
So real quick, where do they draw the line between what's going on locally, a thing like Alexa, and what gets sent to the cloud? At what point
Good question.
do they make the decision?
Yeah. So again, depends on the kind of system. If you have a system that needs to be really low power, but always on, and that's not this, because this is plugged into the wall, so that doesn't matter. But if you have like a watch or something, or your phone, right? Well, that's why Apple buried this coprocessor down in, that all it knows how to do is run really low power and listen for Hey Siri, or whatever. That's all it does. And when it hears something that sort of sounds like that, it saves a copy of the audio, wakes up Big Brother, says, hey, Big Brother, I think they're calling, you know? And Big Brother looks at it and goes, nah, go sleep, you know? Or, yep, that's me. And then it starts processing the audio at that point. Now, if you have a speaker-dependent system that has been trained, and this can even be a system that adapts. So even on your cell phone, even if it comes out of the box as speaker independent, it knows there's just one person talking most of the time, right? There's nothing stopping it from starting to build dependencies and adaptations based on your voice, and it will. Okay, those are gonna start getting boiled down locally. Once they have enough of those, they can start doing actually some local speech processing without sending it to the net. This does it anyhow. I mean, the entire engine's in here. But they're kind of the line where they decide they want to process symbols in the cloud versus down here. That's totally up to the product. And building a product that can do some functionality but then fail over and do better into the cloud is pretty tricky, obviously, in my mind. Anything else?
You just said that your database was 4 gig in RAM.
In RAM.
Yeah, so
Language model.
I would think that'd be the model, right?
Yeah.
How would it be very difficult to do that on a mobile or a portable
Oh,
platform?
and ours was not, it was running on servers, right? So we didn't optimize for that at all.
But if you start talking about building the local adaptation for the specific user,
Adaptations are usually pretty small.
okay.
The ones I was familiar with, we had another engine that was speaker dependent, and the adaptations would be more in the 100K range or something. So you'd have your model and then a bunch of adaptations for people. And every engine's different, you know. I mean, they may find out some really complicated stuff that makes their accuracy better, and you know, that'll blow out the storage or whatever. But again, you got a device like this, and you really only store adaptations for one person, you know, you might be able to use a fair amount. So, anything else before we move on? Let's see, we made it to domain, and domain's a good one. That's kind of where it all happens, and that's where you're going to get all your accuracy. That's exactly what these guys are doing with their skills, is making you define a really narrow domain. We'll talk about that in a little bit. We only got like 10 minutes left, so. Freeform, we kind of talked about that. Okay, so what do you really need? Should you train your own acoustic model language model? No, not unless you have like $1 million or something and a lot of time. And a bunch of research guys sitting around who also want to write papers and then go fly off to Germany for conferences and spend all your money on wine and stuff, okay? So don't do that. Hire engineers, not researchers. There's a difference, people. Collect your own metadata? Oh, hell yeah. Collect everything you know about your speakers. Even if you don't think it's useful, just collect it. You have no idea what you're going to be able to do with it later.
That's how the NSA does all of their speakers, right?
Exactly.
That's how.
And oh, by the way, if you don't know what to do with your metadata, that's actually a good time to hire a researcher. There's this thing called unsupervised training that people are talking about. It's a little bit of a buzzword. So supervised training is what I've talked about so far, which is where take an example of a thing and in this case audio. Here's a stream of audio. Have the transcriber, the human transcriber, type in exactly what was said, exactly on the right timing points and everything, okay? And that is supervised training. That's, I'm telling you what the right thing is. Here's a bunch of them. Use this to train yourself. There really is no such thing as truly unsupervised training. But what is usually meant by, generally speaking, unsupervised is that within a certain set of parameters, the engine itself is going to go look at the data and decide for itself when it sees patterns. And it's going to decide for itself when they're important. One example of this at YAP we like to call, I think we called it the wrapper name problem, because what you have is a bunch of, especially on Metro PCS, a bunch of voicemails. You know, voicemails are coming in, you're transcribing stuff. All of a sudden, this new pattern shows up, and it's got this weird, you don't know what to turn it into. It's got this weird sound, and it turns out it's a new wrapper name, and they like to come up with cool names that have weird spellings and punctuation and stuff in them, and you have no idea what they're supposed to look like, right? So the researchers built this bot that would watch the web, and it would watch for new things to pop up. And in this case, once the wrappers got popular, their name would start showing up, right? And you would have a correlation algorithm that would watch for this stuff, and then try to match things up and go, oh, that's what they're saying. It's this guy here. And you would go ahead and plop it in. And you might have a mechanism like Google has for people to say, no, that's incorrectly spelled or whatever. And then you would start getting some training feedback that way as well. But the first thing was watch for stuff to happen that I've never seen in text before. Try to match it up with stuff occurring in audio that I've never seen before. And that's kind of an example of unsupervised training. If you think of a baby learning to talk, it starts with the machinery that knows how to filter the audio. And it's the baby can kind of understand any language except for a few of the ones where you have to do some really strange physical things. But a baby isn't born knowing English or Italian or French or Spanish. It'll learn the language that it watches. And so it's watching inputs, and it's watching what happens. And after a while, it knows that dada or mama or whatever occurs when these two big pink things are around, and stuff like that starts to form, right? So that's kind of what you can call unsupervised training. That's coming, and it's very cool. That will make your jobs easier if you're doing a speech thing. So know your audio, know your speakers, know your speech domain. Constraints is the same thing as accuracy. The more you can constrain your domains and what it is that people are going to talk about to your product, the more accurate it will be. And that sort of brings us to Echo and Alexa. So Amazon is a pretty smart company, as you know. If you look at what comes with the Alexa Echo skills that you can build, they're actually pretty simple. Some speech scientists would say trivial. It is speaker independent. They have a really good wide field microphone in there. That's nice. It probably understands free-form speech, but they don't let on. They've constrained it kind of into what we would call a grammar model, where it understands things that it has been told. A grammar is just kind of like if you were to go through one of those telemarketing systems where they have you say yes, no, or different words or whatever, and you're walking through the phone tree. That's a grammar, basically. That's kind of what Alexa allows us to build, is these grammars. And in the documentation, they kind of say, for everything you want to build a meaning or an action on, tell us all the different ways that somebody would say this thing. Okay, so they want you to tell them a bunch of ways. But then, to me, that's sort of like, well, that's an easy way to do speech, and there's nothing impressive about that. But I know good and well that they've got more stuff under the covers that they're not telling us about yet. And in fact, in their documentation, they say, and then we'll generalize, okay, on our own. And what that means is they're moving beyond, what's a good way to put it? The systems where you had to type in, basically, here's exactly what somebody has to say for you to know that they said that, okay? You don't care about that. You just want to know, when I say, do you want to go out today, or do you want me to turn the lights on? And, somebody says, pip, pip, cheerio, on we go. It's kind of like, that's not really what you should say, but I know that means yes, so I'll just do it, right? I mean, or if the stoner dude is like, dude, don't be harsh on my mellow, you're like, okay, that wasn't exactly no, but compared to pip, pip, cheerio, I'm pretty sure I'm not supposed to turn the lights on, If you had to type all that stuff in on your own, come up with every response to anything you wanted to do, you lose your mind, okay? And there are plenty of people who have done that already. I would say that these guys are headed in the direction of letting you define a grammar based more on meaning and less on actual words, and that is where you'll get your real work done, because you won't have to worry anymore about, the 50 different ways you can say yes to a question, and the 50 different ways to say an address and things like that. And
How would it figure that out? You still have to train it for those different ways.
they do all that.
They do all
Yeah,
that.
that's what
They
they're going to sell to you.
Synonym dictionary or something?
No, they have a lot of data about how people talk. And it's their job to figure out all the ways that people talk all the time, right? And so they know the 50 ways to leave your lover. Let's just put it that way.
So, am I the only one that's kind of freaked out by the idea of having a microphone in the house listening to me all the time?
No.
Okay, thank you.
You can test it if you have an Alexa home.
Alexa,
You start
are you
saying-
listening to me all the time?
For help with what you can say, take a look at the Things to Try section in the Alexa.
I don't think she picked up my input.
Just start talking about something.
Oh yeah, there's what I do. I think
shovel, a shovel, and then next thing
I
you
got
know,
40 seconds.
On your email, you find a shovel for sale on Amazon.
So I will answer questions as long as I have the room, but I know we have another presentation, right?
Yeah.
Okay, so let's, any parting shots? 30 seconds.
Did you ever come across a product by Applied Data called Bitsy? You familiar with Bitsy's risk board level speech
No,
to text?
I know a lady named Bitsy.
Yeah. It's goes back about 15 years. I can talk about.
Oh, that's fun.
I'll find out. It's kind of
Bitsy and Itsy?
It's a voice processing on a chip.
So they did like a canned voice processor sort of thing. Oh, that's cool. Thank you so much, y'all. It was fun.
Are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life. What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones.
Well, is this? Well, maybe 4 years ago, I used a Microsoft Connect, and I put speech in the house, and the AI in our house was Alice, because when I remarried, my wife has girls, and I had boys, or the Brady Bunch, and we're Alice. And so I was so excited we got speech working, and I turned it on. The next day I went to work, and when I get home, I was like in big trouble, because the speech system had turned the fireplace on, the garage had gone up and down a few times, the lights were flickering, all because my wife had the TV on. And enough things sounded like Alice and the commands that I used. And so after one day, I turned it off. And when Echo came out, I was like super stoked that let's give it another go and see if we can do fire a little bit more responsibly. And I'm amazed because like I was a little nervous with this sitting in front of the watermelon, but I knew it wasn't going to go off unless he said a few key things. And one of those things is the greeter. So I'll do the greeter. Ask greeter to say hi. Oh, you have to say Alexa first. Alexa, ask greeter to say hi.
Hello, Charlotte Internet of Things.
And I also did something with if this, then that to trigger it. And I'm going to show you the if this, then that API as well, because you can code triggers with Alexa without any coding. And the one I've set up for that is Alexa, trigger Spitfire.
Sending that to IFT.
Ooh, double flame. All right. So Alexa has what are called skills, and skills are new capabilities. And so when you you write a program, and those capabilities are called skills. But you can do things like play music, like Alexa, play rock music. Please. Alexa, play rock music.
Power Rock on Prime Music.
So she knows certain skills. All right. She can answer questions. Alexa, be quiet. Alexa, quiet. Oh, she's getting softer. Alexa, turn off. But there are all kinds of skills that she comes with, and she knows the Wikipedia, and she knows a lot of interesting facts, like presidents and things like that. Like, Alexa, how old's the president?
Barack Obama is 54 years old.
So she's pretty impressive with what she can figure out with skills, but it's really cool that you can program your own skills, and the easiest way to do that is using if this then that. Raise your hand if you've ever used if this then that before. So it's like dirt simple to do this. And so before I programmed a skill for Alexa, I tried if this then that, and 5 minutes later I was done. And I'm like, wow, well, let's go try, since that only took 5 minutes, let's go try coding it for real. But let me show you if this then that. So you go to the website, it's just iftt.com. And you log in and go to your recipes. And I think they just changed their interface. So I'll say create recipe and say if this, and you pick on the Amazon Alexa. And oh, this is the old, okay, say a specific phrase, item on the to-do list, ask what's on your to-do list. I want a trigger. I guess we'll try this one. Say a specific phrase. So what phrase will say trick or treat? Create the trigger. And then that. So I'm using a particle photon microcontroller. If those of you who went to the lab today on the photon connecting to Azure, we're using that same microcontroller. And check out how cool this is. It's on if this then that. So I say particle and choose particle and publish an event. You can either publish an event, and that works if you have a lot of different photons, you can subscribe to it, or if you just have one photon, you can have a function and you can invoke a function on just that one photon. So I'm going to say publish an event, because I think it'd be really cool to have a whole bunch of watermelons that would spit fire. You can send data with the event, and like you could do something like watermelon 1 is something, watermelon 2 is something. But for me, the data doesn't really matter. It just is going to ignore it. And then the type of event, if you want other people to be able to subscribe to it, then they can. I'm making this private.
Why?
And then create. So we just created the recipe. So Alexa, trigger trick or treat.
Sorry, I don't see that if trigger.
You need to publish on
It said it's saved, but where's publish it?
Second button down.
Second button down from where?
That's where it says then, there you go.
All right. We'll try it, maybe. I don't know. Alexa, trigger trick or treat.
Sending that to IFT.
Must have published the wrong event. But it went to IFT. Yes, Mike.
How does Alexa customize so that your social media, your if this and that, or your
I wasn't
social
able
media-
to understand the question I heard.
Yeah, you said Alexa.
I wasn't
We
asking.
don't understand like you.
Yeah.
Yeah, that's, that is a problem. I'm wondering how you customize Alexa so that it's household dependent, and people were talking
Yeah.
about multiple Alexas working in neighborhoods and cooperating, and somebody asked how to do that.
Sorry.
Little lag.
But
Delay there.
when you're using the if this then that service, you'll find that sometimes it gets hit with a lot of requests and it's a little bit delayed. But
I believe we call that a hang fire.
I thought that was awesome personally. But it's funny. Sorry for I got sidetracked. Let me go back to your question in 1 second. But I retasked this. I used this for Halloween this year, and I made it so like on my watch I could trigger it, and on the phone I could trigger it. And so we had like 200 kids in the neighborhood. The whole neighborhood party was at our house, and they're all playing in the yard. We survived. But what I found the whole time we had a pumpkin, and I was less like pushing kids away from it, and because I also had it linked to Twitter, and you never know when someone's going to tweet the pumpkin. So I guess I learned something with that too, and what I learned was don't do it, but if you do it, make a big tower and have it be up in the air. So this you're gonna make a huge monster that spits
There's an
fire.
aphorism, it's don't play with fire.
Yeah.
It's pretty simple.
You know, it's kind of like IoT. It's really fun to play with, but so you were asking how do you like control your devices and your things, or
Yeah, your device, your Alexa is going to know about your IoT things and what you say to Alexa, not what other people are saying to Alexa, right?
Yeah.
You're not, if I said something and you had an if this and that, can I have my Alexa trigger it? It's
Yeah.
Because you said,
Absolutely, you could. And the way that Particle Cloud works, and I'm going to show you the code for all this in a little bit, but the Particle Cloud, you can give it a device ID, and you can publish that event or publish that function just to that device ID. And that's actually what I'm doing. I'll show you that in the code. Or you could publish it to a whole bunch of people and have a whole bunch of people's fire watermelons go off, which could be, like cheer lights or something on Christmas. When someone sends a tweet out, you want all the lights to go on.
Well, but it's not customized at Particle, it's customized at Alexa and Amazon, right?
Yeah, so it's because the code I uploaded at Amazon is invoking the Particle API to only access my stuff. Which you're gonna not like the security when I show you that, but give me a second to get to that. Okay, so Alexa has something new. They have a smart home skill set, And it does basic things like turns the lights on and off, turn the fan on to 60% or 70%. And it also discovers things. And so one thing that I'm stoked